Okay, for today's reading, Harvesting Sunlight, as a reminder, you have 9 or more annotations to complete. Again, annotations are not underlining. That is not the same thing. An annotation is a question, a connection, a comment. Maybe you define a word or draw a picture of what you are thinking, or maybe you summarize the text. You have 5 or more annotations from the text that you are reading. And then you have another 4 or more annotations from the images. There are 4 pictures. One per picture is 4 annotations. You can always do more. This will equal a total of 9 or more annotations for the reading. And then you have questions to answer. So let's get started. Harvesting sunlight. Your body needs energy to breathe, move, think, digest food, and do everything else you need it to do. To power all these tasks, your body gets energy from the food you eat. Of course, humans aren't the only organisms that need energy to live. The same is true of all organisms, including plants. However, plants don't eat the way humans do. They have their own way of taking in energy. It's called photosynthesis, and it's the process of absorbing energy from light to make food. If plants can use energy from the sun to make food, can they use energy from any light source for food? How about a flashlight or a laser? Some light sources can power photosynthesis and others can't, depending on the types of light those light sources emit. That's because plant cells only absorb certain types of light, including infrared, most visible light, ultraviolet light, and X rays. Even though a plant's cells absorb several types of light, plants can only use some of those types for photosynthesis. Most plants use the energy from blue and red light for photosynthesis. These are the types of light that help plants grow. The sun is a light source that emits lots of different types of light, including types that can't be absorbed by plant cells or used for photosynthesis. What happens when these types of light come in contact with plants? It depends on the type of light. Some types of light, like radio waves, pass straight through the plants without being absorbed. Other types of light are reflected instead of absorbed. Most plants appear green because they reflect green light. The types of light that plant cells absorb but can't use for photosynthesis change the plants in other ways. Infrared light causes plants to heat up, and ultraviolet light actually damages plants. Too much ultraviolet light can cause plants to die. These different examples show that absorbing different types of light can affect plants in different ways. Some that are helpful to the plants, and some that aren't so helpful. Now, looking at this image before we turn the page over, you can read it says plants absorb most types of visible light. However, they do not absorb green light. The green light that can't be absorbed is reflected instead, which is why most plants appear green. All right, let's go ahead and let's look at this image down here. This is our electromagnetic spectrum, which we looked at yesterday. It says the types of visible light are red, orange, yellow, green, blue, indigo, and violet, also known as Roy G. Biv. Humans can see these types of light, but most of the light emitted from the sun is invisible to humans. So again, this was our spectrum from yesterday. We had radio, micro, infrared, that visible light spectrums in the middle, ultraviolet, X-ray, and gamma. And they've just kind of zoomed in here to show you that red, orange, yellow, green, blue, indigo, violet. All right, go ahead and turn your page over. Next paragraph. Light emitted from the sun. Can plants use light from a light bulb to grow? Yes, if the light bulb emits the right types of light. In fact, some people have figured out how to use light bulbs to grow plants for food in especially dark places like Antarctica. Antarctica gets no sunlight for 6 months of the year. Since people in Antarctica cannot depend on sunlight to grow plants, They use special bulbs that emit a lot of the types of light that plants can use for photosynthesis and less of the types that plants don't need. These grow bulbs emit all the types of visible light: red, orange, yellow, green, blue, indigo, and violet, and some infrared, but they do not emit gamma rays, X rays, ultraviolet, or radio waves like the sun does. So, taking a look at this image, this is a glacier in the ocean by Antarctica. It says Antarctica is dark for 6 months a year, and there isn't enough light for plants to grow there naturally. So, looking down at the bottom, this image is comparing our sunlight and a grow bulb like they use in Antarctica to help grow plants. When sun is shining onto a plant, the sun is giving off gamma rays, X rays, ultraviolet, the visible spectrum, which is our red, orange, yellow, green, blue, indigo, violet, infrared, microwave, and radio. So the sun is giving all of that to our plant. The grow bulbs have been specially used or designed to emit just what a plant needs. So that visible light, red, orange, yellow, green, blue, indigo, violet, and then infrared. Looking at our caption below, it says, "The sun emits all types of light. A grow bulb is designed to emit a lot of the types that plants need for growth and very little of the types that plants don't." Before you move on to your questions, please remember you should have 9 or more annotations. 5 annotations from the actual text, 4 annotations from your images. Now, looking at your questions, they do go on to the next page. You have, what is photosynthesis? Why do most plants appear green? How do special bulbs help plants grow in Antarctica? Why do plants need energy? What types of light do plant cells absorb for photosynthesis? What happens when plants come in contact with types of light that can't be absorbed by plant cells? Can plants use light from a light bulb to grow? On the back of that page, how do special light bulbs help plants grow in Antarctica? What can be concluded about the types of light that plants absorb for photosynthesis? Based on the information provided, what is the purpose of photosynthesis in plants? Why do plants in Antarctica rely on special bulbs to grow? What conclusion can be drawn about the impact of ultraviolet light on plants? What inference can be made about the importance of light for plants based on the information in the text? And finally, according to the text, how do special bulbs help plants grow in dark places like Antarctica? Your assignment is to read your article, 9 or more annotations from the text and images, and then the questions as well.